Hi, I'm Rich Prill with the Washington State University Extension Energy Program. We all want our homes to be safe and comfortable for ourselves and our families. No matter what kind of heating, ventilation, air conditioning system you have, you can save money, save energy, and increase comfort by properly maintaining and upgrading these systems. Heating and cooling account for the lion's share of energy use in our homes, more than 40% of total usage for the typical homeowner. What's more, producing the energy for all these systems contributes to global warming, emitting about 150 million tons of carbon dioxide into the atmosphere each year in the U.S. alone. Here in the Pacific Northwest, more than half the homes use forced air heating or cooling. This consists of a system of air ducts to circulate heated and cooled air throughout the house. Most of us don't give our ducts much thought. They are out of sight, out of mind, usually hidden in a crawl space or attic. However, careful studies have shown that in the majority of homes, these systems are not airtight and often leak large amounts of air. That means you're losing air to the outside that you've already paid to heat or cool. The more these ducts leak, the longer a furnace or air conditioner has to run to maintain comfort. And this means higher utility bills year in and year out. Furthermore, these air leaks can actually cause some serious indoor air quality problems by allowing unwanted contaminants to gain entry from the outside. In this video, we're going to focus on how to stop wasting money and energy in homes that use air ducts for heating and cooling. By properly sealing these ducts, your living space will not only be more comfortable and efficient, but also safer and more pleasant in terms of indoor air quality. Your home's air duct system generally consists of a network of tubes circulating air at a comfortable temperature around and around the house. During the winter, supply ducts deliver heated air from the furnace out of the registers and into each room. Cool air from the rooms is drawn back to the furnace for reheating through the return duct system. Duct systems are usually made out of sheet metal, flexible plastic, or fiberglass panels. Fabrication of these systems in cramped and difficult work areas, like attics and crawl spaces, can often result in some poor workmanship, resulting in unwanted and wasteful air leaks. We're into the house in this crawl space with Mark from the Opportunity Council here in Bellingham. He's going to give us an inspection of the heating ducts in this crawl space.
All right, well, I guess we could start with one of the flex branch supplies. What we have here is 6-inch insulated flex duct, not personally preferred by me. You've got your supports here, your correct support duct strapping, and intermittently we have wires that seem to have been an afterthought in the whole process. Something Rich was pointing out earlier is that we've got a lot of sag in our lines here. This one that we're looking at isn't really quite that bad. You look down the line and you've got a good 6 inches of sag down there. We come down here and we've got our connection with our 6-inch collar to approximately a 12-inch rigid trunk that extends the whole length of the house, connecting to your branches, which connect to the boots, where we get our interior heat. Our primary connection here to the main trunk is our collar, which, let's see here, we've got, well, duct tape and 2 mechanical fasteners, which, as you can see, in the past 30 years have failed miserably.
Oh wow, look at that.
Yeah. So, yeah, this is a Panduit strap that has failed. It's come off. No mechanical fasteners were sent through your flex into the rigid, so this is inevitably what's going to happen there. You're heating the crawl space, and the rats are loving you for it. Going on down the line, here we have these tabs. You're supposed to give it somewhat of a tight connection, but it's definitely not ultimately a good sealing measure here. So what the plan is with these tabs, I'm going to pull those in, put some more fasteners in there, some mesh tape and mastic, and that's going to give us a pretty darn good seal. Wrap that with MBI, tape it, and twine it, and that's definitely going to be a very, very good air sealing / insulation measure. What we've got here is a big health and safety issue, is fiberglass in your duct system, and a great thoroughfare for rodentia.
Here's another indoor air quality issue with this house. We've got fiberglass insulation, and here's one of our disconnected ducts, and you can see we've got lots of rat droppings right next to these air leaks. Obviously, when the system isn't running, air can move into the house from the crawl space, carrying these potential contaminants with it. Using this chemical smoke, we're going to check this leak just to get an idea of how much air we might be losing out of the duct system. You can see that a small hole moves a lot of air. In fact, studies indicate that a 1 square inch hole in a supply duct may result in the same heat loss as a 20 square inch hole through the side of your house. For homes where the ductwork is contained within the insulated building enclosure, the energy loss from duct leaks is generally not a big problem. The ducts are leaking to the inside of the home, not to the outside. However, in unheated attics, crawl spaces, basements, or garages, air leaks mean heat escapes to the great outdoors, adding up to as much as an additional 10 to 40% increase in energy usage. We're immediately beneath the furnace that's mounted upstairs, and this is the supply plenum. It's under the most pressure, has the hottest air in the heating system, and then that's connected to this trunk duct that delivers the air down to the branch ducts that terminate in the rungs. And any leaks here, of course, are the most important because that's the hottest air. And you can see that they've done some sealing here, but it's not fully effective. This is also not insulated. The heat loss from the ducts somewhat protects these pipes from freezing. When we insulate and seal the ducts, these might be subject to freezing in a vented crawl space. So we'd want to protect those with insulation and possibly some electric heat tape that's thermostatically controlled to keep these from bursting during cold weather.
Well, we're going to rip out all of this. We're going to stick R19, which the specs, they call out for R8, which, in my opinion, should be changed. It's just
so more insulation is better.
More insulation and correctly placed insulation using twine. The MBI has kind of a poly coating around it, which is another protective measure for the insulation itself. And we'll wrap that up not too snugly. We don't want to compress the R value. We don't want to lower that at all, but we definitely want it to not be able to move. We don't want gravity to take advantage of that.
So I think what you're saying, Mark, is you're going to add more insulation than what's required today,
yes,
because you don't want to come back and do this later.
Exactly, yeah.